This is about orbits around the Sun. Let's say this is the Earth orbiting around the Sun, and we know that at this orbit, the period is exactly 1 year. So if we want to arrange for a satellite to orbit around the Sun with a period of 1 year, shouldn't we arrange it to orbit at the same orbital radius as the Earth so that it has a period of 1 year? I mean, we want its period to be 1 year. Maybe we should first revise this thing about orbital period and orbital radius. Suppose we put a satellite here and it's doing circular orbits around the Sun. The only force acting on it is the gravitational pull of the Sun. So the gravitational pull of the Sun provides the required centripetal force, which is mr omega square. So let me write the gravitational pull as G m over r square equals to the required centripetal force. So from here we can rewrite the equation, put the r's together, and of course the mass doesn't matter, so you got omega square to be gm over r cubed. Now what's important is to realize that at each orbital radius there is a particular angular velocity and therefore a particular period. Alright, let me say it again. If the orbital radius increase, right, if r increase, you see that omega should decrease. So if the orbit is further away from the Sun, the period should lengthen, should become longer and longer. So we know that at this particular orbital radius, the period ought to be 1 year. This is where the Earth orbits the Sun. Alright, so if you move it closer, back to this one. Now this orbit has a period of 1 year because the gravitational pull of the Sun is such that the centripetal force is such that you end up with a period of 1 year. So if you have a orbit that's closer to the Sun, the gravitational pull will be stronger, you have a larger centripetal force and acceleration, and therefore the period ought to be shorter. If you plonk the satellite further away, then the gravitational pull of the Sun will be even weaker, and the centripetal acceleration will be even smaller, and therefore you expect a period that's longer than 1 year. So how is it possible for this satellite to be orbiting at a radius smaller than the Earth's orbital radius and yet have the same period of 1 year? The reason is we have arranged for this satellite to be always sitting somewhere between the Sun and the Earth. So the Earth is here, and we make sure that the satellite is in between these two large masses. What this means is that this satellite will not be experiencing just the gravitational pull of the Sun, it's also experiencing the gravitational pull of the Earth, but in the opposite direction to the centripetal direction. That means this satellite here will not be experiencing a net force of Fs. Instead, you'll be experiencing a force that's smaller than Fs because the net force is Fs minus Fe. So because the net force is smaller, the effective centripetal acceleration is also smaller, and therefore the period will be longer, will be lengthened. So the period here will not be the period that it would have been if only the Sun's gravitational pull was acting on it. Alright, so the Earth's gravitational pull serves to reduce the net force and therefore reduce the centripetal force and acceleration, and to lengthen its period to be back to 1 year. Okay, I hope I've made it clear enough. See you, tata!